Thank you for watching my video. My name is Mr. Charles Weniken. In this video tutorial, this is passive components in resistor part 2. I have discussed the part 1 already. I differentiate difference between active and passive. I also gave an example of passive component. So resistor is one of the passive component example that I gave, which I also differentiate types of passive component, which we have dissipative and lossless passive component, and resistor fall under dissipative passive component. So in that case, let's start with resistor. A resistor is a passive component that opposes the flow of electrical current through it. From the definition here, what I want you to understand is a resistor is a passive component that opposes the flow of electrical current through it, which means that, for instance, I want to use a policeman as an example to explain this opposing of flow of current through it. If a policeman will come to arrest you in your house, and a policeman they now said you stole something, or you do one thing or the other, and you are under arrest, first thing you will do, you will ask, what are my offense? They will explain, and if you are not sure of what they explain, that you are the one that did it, you must resist the arrest. That's resisting of the arrest. It means that is the same thing, the same work of resistor. That is what it does. A resistor is a passive component that opposes the flow of electrical current through it. As you are opposing, you are telling the policeman that you are not going with him or her, whosoever. That is the same thing that resistor is doing. The amount of opposition to the flow of current is called the resistance of the resistor, and the symbol is denoted as in R. So that is the simple definition of a resistor. And the symbol of resistor is denoted, the symbol is R, being arrow here, capital. Now, resistors act to reduce current flow, and at the same time act to lower voltage levels within circuits and to adjust signal level. And if I am to explain adjust signal level, it could be a voltage, it could be a current. Now, in terms of resistor, we have various types of resistor, and the one that adjusts energy or voltage or current is called variable resistor. And in variable resistor, it adjusts signal, either increase or decrease. So in this case, to adjust a signal level, you use a variable resistor to adjust it. Now, resistor acts to reduce current flow, and I have discussed difference between current and voltage is in my YouTube channel, Charles Electronics. Go there and watch difference between current and voltage, and at the same time it acts to lower voltage levels within the circuit. So go there and learn what is the difference between current and voltage. Voltage is always constant, waiting for current to come. So go there and watch difference between current and voltage. That is the work of resistor. resistor had to reduce current flow and at the same time how to lower voltage level within circuit and to adjust signal levels. Resistor may have fixed resistance that only change a little with temperature, time, or operating voltage. This one will be explained when I will be specifically teaching resistor, because I will also make a video series on resistor, and that video series I will treat everything about resistor, and that's where you will understand the fixed resistance that can only be changed a little with temperature, time, or operating voltage. And you know what temperature, then you know what temperature means, as well as time or operating voltage. Now, variable resistor can be used to adjust circuit elements, for sure, just as I explained before. Variable resistor can be used to adjust circuit element, such as volume control or a lamp dimmer, or as sensing devices for heat, light, humidity, force, or chemical activity. The unit of resistor is called ohms. The unit of resistor is called ohms. Now, I mentioned variable resistor earlier before this time, which I told you that it can be used to vary, as in increase voltage or decrease voltage. It could be current, it could be voltage. That is the work of variable resistor. That is the main function of variable resistor. You can also see it in stabilizer. You can also see variable resistor in many electronics circuits. Is in television sets, television circuit, or television motherboard. Is also in stabilizer. You can see those things there. You can see variable resistor there. That is what they do. They vary either to increase. This word adjust, it means either go front or come back, up and down. So that's what I mean by that. Now, 1 ohm is value. One ohm is the value of resistance that rises when a current of 1 ampere flows through a resistor that has 1 volt across its terminal. What I'm trying to explain here is a ohms of resistance that rises when a current of 1 ampere flows through a resistor that has 1 volt across its terminal. A resistor, it has 2 terminals, 1 leg here, 1 leg here. Now, each time, just remember, as I said, voltage is always constant. Why? Current. Voltage pushes the current. And the unit of voltage is volts. Why? The unit of current is amps. And the unit of resistor is what? In ohms. So in that case, if 1 ohms is the value of a resistance that rises when a current of 1 amp flows through a resistor that has a 1 volt, you can see it now. 1 volt across its terminal, which if a voltage is, or current, or 1 ohms is rises from 1 terminal to another terminal. That is what I'm trying to explain here. 1 ohms is the value of a resistance that rises when a current, and before a current will move, there must be a voltage, because voltage push the current. Voltage can move without a current, while current cannot move without a voltage. So that is what I want you to understand here. Current cannot move without a voltage. Why voltage can move without a current? That is just the simple truth of it. Go to my YouTube channel, Charles Electronics, watch difference between voltage and current. You will understand it more better. Then the resistance of a resistor can be defined in terms of the voltage drop. Remember, then the resistance of a resistor can be defined in terms of voltage drop across the resistor and the current flowing through it as related by Ohm's law. By the way, is here already. This is a symbol of the resistor, while this one is a symbol of voltage. This V stands as in voltage. This arrow stands as in resistance or resistor, while this one here stands as in current. What I'm trying to explain here, with this symbol that is here now, voltage or current pass through plus and give to negative. Now, from what I say, from what I explained from the other, from this one, say 1 ohms is the value of resistance that rises when a current here. 1 ohms will rise when a current is passing through a resistor. And a current cannot move without a voltage. Remember, a current cannot move without a voltage. So that is why voltage must be there, pushing the current to go forward. As soon as it enters straight to the resistor, 1 ohms of resistance, they say 1 ohms is the value of resistance that rises when a current of 1 amp flow through a resistor that has 1 volt across its terminal. Simple. This is the first terminal, while this one is the second terminal. In all, I summarize it here. Here we have current. I stand for current equals to V all over R. That is the Ohm's law. Where R is the resistance, V is the voltage across the resistor, just as I explained before, and R is the current flowing through the resistor. Now, this relationship between the voltage and current, called the VI current relationship, that is voltage current relationship in a resistor, is linear in both direct current and alternating current, being DC current and AC current circuit. The relationship between the voltage and current is called voltage current relationship. In a resistor is linear. You know what is linear mean? Linear, it means something that is a straight line, linear, straightforward. It's linear both in alternating current as well as in DC current circuits. The power absorbed by a resistor is represented by this. P is equal to V dot R, being P represents as in power, while V as in voltage, I as in current. I repeat, the power absorbed by the resistor. When the current and voltage are passing through the resistor, definitely there must be a power that absorbs, and the resistor will absorb the power, as in power will be absorbed. In that case, it's represented by P is equal to V dot I. Now, after all the calculations has been done, which we finally, at the end of it, the unit of power is in watts, which we have what? We have current square multiplied by resistance, which means that the voltage has been eliminated. In terms of power, voltage has been eliminated. The power absorbed by the resistor is represented by this, and in that process, voltage has been eliminated. And the one that we are going, the end product is current square multiplied by resistance, and the unit of power is in watts. An ideal resistor will dissipate electrical energy without storing it as electric charge or as magnetic field. That is in terms of ideal resistor. When I will discuss or when I will make a video on resistor alone, I will explain each and every one of them. Two types of resistor. Resistor comes in two different types: fixed and variable resistor. Fixed and variable resistors. The fixed resistors have a specific and predetermined value and are unable to change. You know, whatsoever thing that has been fixed, it has been fixed. It will never be changed. That is why it is called fixed resistor. You cannot change it. It's always there. And is different from variable resistor. A fixed resistor is different from variable resistor. That is why I say the fixed resistors have a specific and predetermined value and are unable to change. You cannot change a fixed resistor's value. That is why when people choose fixed resistors, they should also need to consider the values as well as the tolerance and the upper power rating to make sure it will work properly with the device. In case, if you are building or if you are a technician or whatsoever thing, what I'm trying to explain here is any changes that you are making, or if you are about to build any circuit, if you are to buy a resistor or you want to buy a fixed resistor, all these things that I mentioned, the value as well as the tolerance and the upper power rating to make sure that it will work properly with what you are about to do. You know, majority of our technicians today, what they do is once they remove 100 ohms resistor, they will not put exactly that 100 ohms and the tolerance. They will put below. And in that case, that means it will affect that circuit or a motherboard. So for you as a good technician, you must be very careful if you are working on fixed resistor. The tolerance will let them know the performances, boundaries, while the power rating will show the upper power limit the resistor can handle. That is how it is. All those things that I mentioned, all those things, it will help to tell you the performances and the boundary of that resistor, while the power rating will show you the power, the upper power limit that the resistor can handle. Because each of them, as long as is a fixed resistor, they have a specific power that they can handle. Two different types of fixed resistor. Two different types of fixed resistor exist: metal film and carbon. Try to understand what I'm trying to explain here. There are two different types of fixed resistor. It has metal film and carbon. Carbon resistors are good for general usage and are generally cheaper. The multi-fin resistors are high quality and are best when the device needs a higher tolerance. From this now, you can now know a specific phase resistor that you are changing. I will discuss all these things during resistor series when I will teach or discuss on resistor. All these things will be discussed much more in details. So what I'm trying to explain here is with this now, you can now know that there is difference between carbon resistors and metal film resistor. The metal film resistor are highly quality and are best when the devices needs a higher tolerance, while the carbon resistors are good for general usage and are generally cheaper. Both of them are good, all depending on what you are about to do or to build. Now we have variable resistor. The variable resistor is different from fixed resistor in that it lets the user have control over the amount of resistance in the circuit. Just as I said, variable resistor is it enables the user have control over the motherboard or the circuit that you are about to work or to do. Variable resistor will help you either to increase the voltage or current or to decrease it, all depending on what you are doing as of that particular time. So in that case, the variable resistor is different from fixed resistor. In time, in that it lets the user have more control over the amount of resistance in the circuit. When the resistance increases, the current decreases, vice versa. It means that when the resistance increases, the current decreases, and when the resistance decreases, the current increases in times of variable resistor. The variable resistors have two components. The element is the material that provides the resistance, and it is on one of the two track types, either logarithmic or linear. The other component of the resistor is the movable component, and this allows one to set the resistance. I will as well show you the linear and the other movable component of it when I will be discussing on or teaching on resistor series. You will see those things that I'm talking in terms of movable and non-movable variable resistors. Now in that case, we have surge protection component. This surge protection component is under resistor. Surge protection component, a varistor is voltage dependent resistor. We are now talking of another aspect of resistor, which work as a voltage. It helps to protect a circuit or a motherboard. The resistance of a varistor is variable and depending on the voltage applied. Their resistance decreases when the voltage increases. In case of excessive voltage increase, the amount, the most common types of variable VDR or being varistor dependent resistor is called metal oxide varistor, which you can also call it MOV. I will also talk on this during the resistor series. I am just trying to give you an introduction aspect of resistor in terms of passive component. If you don't get or understand it initially, you try to rewatch the video once or more 2 times, you will really understand what I'm trying to explain. Thank you once again for watching my video. If you find my video useful, please subscribe to my channel, comment, and like. Expect more video from me. Thank you once again. See you in the next class.